We're going to be talking about how LLMs run code today. Now, the short answer is they don't actually run code. They can't run code, but they do write a lot of code. And a lot of applications will execute code that is run by LLMs. And it's not the easiest thing to set up. And there are a couple of things that I think are important if you want to actually run code that is executed by LLMs. So that's what we're going to talk about today. We have an application that I built called Data Diver, which looks at data from data.gov, which is a aggregation of a lot of various data sets from the federal government. They come in different formats, they come from different sources, and they're very painful to work with. The search is not very good, and it's impossible to know what's in a data set without actually downloading it. Data Diver gives you nicer summaries, gives you a much better search, gives you a preview, and also allows you to generate graphs and charts on the fly for these data sets. And so if we can see, we're looking at the alcohol beverage licenses in Louisville, Kentucky. And just looking at the preview, we see the geometry. So that would be latitude and longitude. So that would enable us to create a map. And we also see stuff like the type, I guess, license cat. So the column name is not really that helpful, but the data makes it clear what's in here. And we also get stuff, the business name, Stop and Go Food Mart. I'm sure that's a respectable establishment. Party Mart, all right, we like that. Ole Frijole. So obviously a lot of fun to be had in Kentucky, but we actually want to go and generate some graphs. So, okay, here's what we're going to do, because I really like Ole Frijole. So map, create a map of all of the points. Use a red dot for all of the points. Use a big yellow star for Ole Frijole. All right, let's see if we can do this. I want to know where Ole Frijole is. It sounds like a really fun place. So I'm having it generate the graph now. Oh, there it is. There is Ole Frijole. We'll have to stop by at some point for a beer. But here's the graph. Now, like I mentioned, LLMs are not able to run code. My application, of course, is running code. This is not a canned map that I just pulled up. And if we take a look at this drop down here, we can see the Python code that it actually generated. And where I actually ran this is pretty interesting in my opinion. So first of all, I'm impressed that it was able to grab out Ole Frijole, convert the latitudes and longitude into the correct coordinate system, and grab the base maps. That would be the background for what we're seeing here. But the way that this code ran is very, very important. I didn't just grab the entire contents of the script, dump it into a Python file, and run it. And the reason I don't like that approach is, first of all, we have this data. So GDF didn't just come from nowhere. I told the language model that you're going to have a variable called GDF, and it's going to contain everything you see in the data set. So I want to avoid copying around a large data set. This one's not too bad, only 1,500 rows, but there are some data sets that have hundreds of thousands or even millions. And so if you have to be making copies of these, it's just going to be slow. So you want to avoid that as much as possible. Some of the other requirements, we didn't get it this time, but it's very likely that these language models make errors. And so you want to be able to recover from that. Maybe I can do something that's a little more complicated. Also do a blue star for any liquor store. So I don't know if it's going to be able to do this. Oh, I spelled star wrong. So I'm really confusing. I'm kind of goading it into making an error so I can do a demonstration. Oh, it did it right away. Okay, excuse me. I'm trying to trick the AI, and it's proving to be wiser than I initially thought. But regardless, if it were to make an error, and let's say this data set had 1 million rows. If it has 1 million rows and we're doing a big operation and then it makes an error 90% of the way through a long script, if it's just a raw Python script, we'd have to start from scratch. The whole process would be killed and we would have to pick up from the beginning. What I really want to have happen is for there to be checkpoints. And so if it makes an error, I want it to be able to recover exactly where it was. That is an absolute must in my opinion. Now, this Python script as you probably have noticed, is not just a normal Python script. This looks like an IPython session. In fact, it's a fake IPython session, what you're seeing on the screen. And to the language model, it's role-playing as a data scientist that's writing an IPython notebook and debugging it. That's what I've tricked it into doing. It's doing an impression of a data scientist writing an IPython. That's what it's doing for me. Now, IPython is this application here. It's used by data scientists, a lot of people in machine learning, and this saving of the session is one of the main draws. So if you have some massive array and you are playing around with it, you don't want to have to keep restarting the script if you make an error. So I'll show you what I mean by the errors allow you to recover. So if I do something like x equals 1, then I create a new cell, y equals 0, and I create a new cell and I do something a little bad like x over y and I run that, it says, oh, 0 division error. But then I just pick up in the following cell and I can do, oh, y equals 2. And then I can say, oh, well, x over y, 0.5. And notice I did not have to redefine x. So this is obviously a very contrived example, but this is the power of the IPython session. And just some terminology. Jupyter is the front end and the server. IPython is the kernel and the backbone and what is actually controlling the session and keeping the state around. So just a little distinction there. We're going to actually go into my PyCharm now, and I'm going to show you a few things. I have this class that's called IPython wrapper, and you can actually embed an IPython shell into a Python program. And not only can you do that, you can pass data from we'll call it the regular Python program into the shell because it's actually running in the same process. So if we go over here, and yeah, this didn't work. So let's do green. And then I'm going to generate the output. Actually, I need to run this in the debugger. So let's kick this off in the debugger. And then I'm going to regenerate this output. Here we go. And notice we have this thing called user ns. So this is how I pass data into the shell. And if we look, we see this variable called GDF. And here is the full data frame, the entire contents, all 1,492 rows. And so that's how it's going to have access to it. Then we come down here into this execute command. So when I hit play, we're going to go out to the LLM, grab the script, and then we're going to be here in execute command very, very shortly. Now, notice that the command string, which we see up here, is just one line. So let's click play. Doing another import. I think it might have made a mistake. Oh, no, it didn't. We were good. So we see here that we're going line by line instead of just dumping the entire thing in. And actually, if we go up into where is the script? So if we look at the script, what it returned to me was not just raw string. I actually had it return to me a list where each string in the list is a line that I'm going to execute one by one. And so the fact that I'm executing one by one, if one of these has an error, let's see if we actually run into an error. I don't know if we will. That could have been an error. Nope. So if we were to run into an error, I have this wrapped in a try catch, and I'll show you that up here. If we run into an error, what I can do is grab the output and then now go back to the LLM and say, hey, you're this far deep into an IPython session. You've written all this stuff. Here's the final error you got, and here's what the user wanted. Fix it now. And then it will go and do that. And so this IPython is really, really useful for this.